What I would try to address here is attempt to place before you a framework which would allow us to pose the problems and try to work for a solution towards addressing the agricultural management issues in the context of climate change. Along the way, I'll try to indicate some of the leading studies which are going on in the world in trying to look at these and how we can take the learning from that into our own programs. So the presentation might appear academic, theoretical, but then in the context of climate change, I think a lot of theory needs to be understood before we can start looking at the practical issues. And at that point, I'll also try to bring out how the ICTs can enable us to actually build such a framework and work towards a solution. So, what's important here is to understand that when we are dealing with agriculture and climate, we are looking at complex feedbacks between both the systems, between the agriculture production systems and the climate cycle. So when you look at the agriculture production system, you are talking about essentially production as a function of the natural resources, the land use that is on the natural resources, the climate, the socio-economic context, and what we do to manage that through inputs and technologies. Now all of these vary with location. So basically each of these is a geospatial phenomenon. The climate, the socio-economics, inputs, technology, they control again what is fed back into the atmospheric cycle. So to deal with such complex feedbacks from between one, climate impacting agriculture and agriculture impacting climate on the other, we try to classify the resources, classify our land units. So if we take the first three, the natural resources, land use and climate, the normal process is to classify the resources into what we call the agroecological zones so that you can address the problem, frame the problem in land units of agroecological zones. And then the socio-economical conditions which determine how we use the inputs and technology. When we put the two together, then we have what is called an agroecosystem or an agricultural production system. So to address first of all the problem in the context of climate change, we need to classify our systems into agriculture production systems, look at how climate feeds that system and how this system feeds back the climate. And since all of these are varying in location, we have to have a geospatial framework to address these concerns. Now, these classic examples of classifying these land units, FAO has done it. FAO's agroecological zones were done in 2002 with the very purpose of classifying the globe into units for addressing climate change impacts, the climatic vulnerability of agriculture to climate change. So, like I said, I keep giving you certain key developments in the science and application so that we know how this has evolved and how we can work further. Looking at the specific forcing from agriculture, the main issues to address are methane emissions from rice fields, nitrous oxide coming from the fertilizer applications, carbon dioxide emissions from energy use, which could be through farm energy, through transportation of farm materials, through also burning of residues, and carbon dioxide emissions which can change because of the land use changes. And if you look at the impacts of climate change on agriculture, we are talking about physiological impacts specifically on crops on the one side, which leads to crop shifts and reduced yields, changes in temperature and rainfall patterns, largely in terms of frequency and intensity of rainfall, which is what we are expecting. If you look at the Indian data for the last 60 years and take the 31-year moving averages, IMD has done that analysis, you will find that traditionally July has been the highest rainfall month in the country. But if you look to the last 30 years, you find that July rainfall is becoming less than the August rainfall. There are clear shifts in these patterns. There are certainly the events with high frequencies of rainfall, greater than 150 millimeters per day, they have shown a general trend in the last 20 years. So even if the total rainfall may not change much, we are probably going to have that total rainfall come down in fewer rainy days. So you're going to deal with much more severe problems of erosion, water conservation, etc., which are very relevant to agriculture. So automatically, with these changes, you would also expect changes in the land quality, in the soil quality, and the water quality, which will impact quantity and quality, which will impact the production systems. So there is a shift in spatial and temporal distribution of these climate events. And in this context, since particularly in India and the developing countries, agriculture is closely related to the livelihoods, the impact on the livelihoods of climate change has become, again, a very serious very serious concern being studied now across the world. Besides these impacts, we should also recognize that these are multi-scale impacts. They can have impacts right from the farm and household level to a regional level, to a national level, to a climate level. So complex feedback cycles which vary in space, multi-scale effects, so you have to put these in a geospatial framework. So the geospatial framework essentially provides the platform to assemble data of these resources, natural resources, which might include soil, climate, which might include rainfall, weather, etc., the crop itself, the land use patterns, the livelihoods, according to the location. And because you can assemble them according to the location, it provides you the means to characterize the systems to the units you can really analyze. Once you have characterized it, then it also provides a mechanism to integrate the knowledge now, which has grown tremendously in the last 20-25 years. The process knowledge on how crops interact with the soil, plant, atmosphere continuum, what are the processes that go on there, how those are being used today now in the context of climate change. I'll briefly come to that too. And the crop and both the land surface processes, the hydrologic processes, which are having a tremendous impact, with the climate change models themselves, the models on the climate change, the GCMs, etc. So it So scaling of impacts is another facility which comes from that, and integrating with policy and regulatory mechanisms now, because increasingly countries have to account for the nitrous oxide emissions, for the carbon dioxide emissions, and for the methane emissions into the world environmental records. So it provides again that means for providing those records so that the environmental indices can be appropriately mapped and according correction mechanisms can be taken subsequently. So how do we enable the whole process then of doing this? There are issues to be addressed at two levels when we deal with climate change. One is the supply side of it, where we are trying to assess at the ecosystem level the broad impacts, and where the real issues are finding this data, finding and accessing the real world spatial data. You might have the tools of the geographic information systems and so on, but then where does the data come from? Finding and accessing the data is a very critical issue. Accessing the spatial analysis tools for analyzing this information, these are again major issue on that side. And then integrating these tools with the domain knowledge which is happening in the water management side on the hydrology aspects, which is happening in the crop management side on the crop nutrient cycling, the whole crop growth modeling processes. How do we integrate those? And then on the community level, how does one use this knowledge to take appropriate decisions at the community level? That means assessing and managing the local resources, which is what was touched upon in the previous presentation from ICRISAT. So identifying the stakeholders, resources and constraints, stakeholder participation for the data collection locally, then linking the resources and constraints with stakeholders, and then integrating once again these spatial analysis tools, and providing for the feedback between what happens at the community level decision making and how it impacts the larger scale on climate. So what we have come up with at NARM under this project which we are doing jointly with Dr. Balaji and the IITs and so on is try to address this problem at two levels. The e-enabling part. One, we make a centralized repository of data, what we call a geospatial library, a concept which originated in late 1990s in Harvard, and then subsequently a few institutions have taken it up. To provide this web-based access to data first, the tools, services, and knowledge resources, all of them combined in that library, so that users can, for the systems they are working in, characterize the systems locally and then apply these tools to see how the systems are actually responding to different types of decisions. And on the demand side, at the community level again, having the local village level knowledge center, because in India today now, every village a knowledge center is the goal, and already we have gone quite far ahead towards meeting that goal. So the village knowledge centers are now a reality in most of the villages, and use this facility to again e-enable the local resource data and knowledge and put them together there. So just to give you an example of what we are trying to do at NAM, we built a geospatial library which gives access to spatial data, attribute data, learning resources, and the spatial data structure includes at the state level for this state of Andhra Pradesh information on the soils, on the watersheds, on the markets, at the state level, at a district level, at a local mandal level, and we have drilled down to the village level in the case of a few mandals where we are working on specifically. And then the attribute data, again databases on at various levels, on the crops aspects, on the production aspects, on the weather aspects, and so on. And learning resources, how people can directly learn from these resources using the training manuals, GIS applications, etc. in agriculture and so on. We also, just to run through these, this is the watershed which we can extract for the region we want. The watersheds are available right up to micro watershed scale. The agricultural markets we can take out district-wise, we can take out mandal-wise and analyze with reference to where your study area is to get the socio-economic relationships. Then the users can view the data, they can download the data, and also download the data in a spatial format of shape files and work with them at their own level. For districts, these are the, again, this is the download process for the users. Then the learning resources which are available on both on the software aspects as well as the knowledge base on how to use them. Drill down to the district level by interactive selection from the map directly. So within a district, drill down to the mandal level on different aspects, on different soil properties or all those attributes related to soils and watersheds. Then the attribute data for each at the state level and the district level available as MS Access databases which can be downloaded and used by people directly. And at the village level also a similar structure which is built at a cadastral level from the Survey of India maps and cadastral maps, with the database up from survey numbers to farmer numbers on the local resources, etc. So this spatial database created in a cluster of villages, and then the data is made available at the village knowledge center, and then our scientists working with CRIDA, the group which works in this area too, are able to communicate the resources, information, and try to involve the farmers in the decision-making process. So a point I want to stress before I close is the feedback cycles are extremely important. You have to approach these problems at different levels. You approach it at, let's say, the land use, soil conservation, the water cycle. We have the classic example of the humus model in the United States, hydrologic unit modeling of the United States. The whole country has been modeled in very small agriculture watershed level, where the knowledge of the soil and the water cycles, the soil conservation processes, the engineering aspects of conserving and estimating the impacts in terms of runoff, in terms of water quality. The hydrologic knowledge is available. The way to structure it into a geospatial framework is available. Now, on that framework, if we look at the data from the climate change models on how the rainfall changes, how the rainfall intensities are increasing, we would be able to make better assessments of what happens to the soil loss. From soil loss, we have mechanisms of estimating what happens to the crop yield losses. So there is a way of working through from at each agro-production unit level in a geospatial framework of assessing practically all the aspects which have an impact on climate change. On crop productivity aspects, we have significant work done in India also, but at the district level, not below that. So each aspect can be fit into a geospatial framework and analyzed. But then the main problem in approaching this is that access to data, information, knowledge resources. And that is where the e-enabling comes in. And the geospatial library is one mechanism by which we can probably enable people to access, analyze, develop the theory, put in the framework, and then forecast and accordingly take the decision subsequently. Thank you.